Australia is the driest inhabited continent on the planet, and right on its western edge sits Perth, currently the fastest-growing city in the country. Between 2022 and 2023 alone, the metropolitan area absorbed 80,000 new residents, driving a massive surge in demand for basic utilities. Every new subdivision pushes outward into an unforgiving, arid landscape. The local infrastructure must support this expanding population with a practically non-existent natural water supply. The sheer volume of people moving into a region that inherently lacks rainfall sets up a direct mathematical collision between human expansion and geographic reality. Historically, the city survived by capturing natural precipitation. Back in the 1960s, a network of active dams supplied nearly 90. This chart illustrates the failure of the traditional water system. Since the 1970s, rainfall in southern Western Australia has decreased by 20%. Because the dry earth absorbs moisture first, that 20% deficit triggers an 80% reduction in actual water flow filling the reservoirs. By 2030, projections show rainfall dropping by another 15%, pushing the reservoir flow rate perilously close to zero. Relying on the sky for survival is no longer a viable strategy. The city's existing dams are now obsolete. To secure its future, the regional utility, Water Corporation, initiated the Australia Water Strategy. This policy abandons passive rainwater collection in favor of actively manufacturing potable water. Today, nearly one-third of the city's supply comes from processing ocean saltwater, a highly energy-intensive extraction method. But the city is also deploying a second extraction technique deep underground, mining its own urban sewer network. The daily output of 1 million households acts as a dense, untapped reservoir of raw materials. This is the Woodman Point Water Resource Recovery Facility. It currently processes 150 million liters of wastewater from nearly 900,000 homes and businesses daily. The existing infrastructure extracts up to 78 tons of organic matter and sludge daily. With the recent influx of residents, that throughput is falling behind demand. To break this bottleneck, an upgrade led by WeBuild Group subsidiary Clough is pushing the plant's capacity to process 120 tons of organic matter daily. The operation begins by mechanically stripping the clear water from the incoming flow, filtering it until it is entirely safe for reuse. Once the water is removed, the thick remaining sludge goes through a physical separation process to isolate what the facility calls biosolids. These highly concentrated organic materials are then exported to regional farms, acting as high-grade fertilizer to cultivate large-scale wheat, oat, and canola crops. Woodman Point physically dissects raw sewage, sorting it into distinct, economically viable commodities. The treatment process also releases a third critical byproduct, highly volatile biogas. This schematic shows how the captured biogas is siphoned off from the organic waste and routed directly back into the facility's generators. This internal loop produces enough electricity to cover nearly half of the megaplant's total power consumption. By capturing and burning the gas internally, the system prevents it from entering the atmosphere, reducing the facility's greenhouse gas emissions by roughly 5,600 tons every year. The infrastructure operates in a nearly closed loop, sustaining its heavy industrial processes by consuming the byproducts it creates. Using this facility as the benchmark, the Water Corporation has set a strict operational mandate to recycle 35% of all wastewater in the Perth metropolitan area by 2035. That level of efficiency is a necessary defense mechanism against the brutal, parched landscapes left behind by events like the tinderbox drought. As the global climate continues to warm, the extreme aridity currently confined to Western Australia is projected to become the baseline reality for metropolitan areas across the globe. Sustaining dense populations in the 21st century requires the extreme engineering capacity to infinitely recycle the water we've already extracted.
And that wraps up today's Explainer. Seriously, what a fantastic deep dive into those mind-blowing engineering concepts. I just want to say a massive thank you for sticking around and completing this journey with me. So let's get into it. Did you find these complex engineering concepts as utterly fascinating as I did? To get more amazing construction content, just follow this blueprint. Thumbs up, share, subscribe, and hit that bell. Trust me, that notification bell is the absolute foundation to ensure you never miss our next upload. Which leaves one final question. What incredible structures are we going to build in our very next adventure?